defined area and determine the amount of solution that you put on over that. But when you get into the manipulation, assume that you were talking about the boom spray. If you didn't put down as much water as you needed to, there's several ways that you can adjust that. Whether you're looking at increasing your nozzle size will help. Increase the pressure on your spray on that device, which would, in theory, put a little more down. You can slow your tractor down, which will that. By the same token, if you put down more than you needed, you can speed up the tractor or reduce your pressure or reduce your nozzle size. Those are three of the primary ways that you can change that. But quite often, if you don't want to manipulate any of those factors, if you're comfortable with the way the tractor was traversing the area that you were doing, and you were comfortable with the degree of wetting, that's one of the things that we're always concerned about is make sure you put down enough of the carrier, the water solution, to wet the surface of the land or the weeds, whatever you might be doing. If you're satisfied with that, you can then adjust the rate of application by the amount of pesticide that you put into the tank. And these are all factors that we need to talk about as we do. If you're not happy with your application rate on a little knapsack sprayer or your handheld sprayer, that's a little harder to deal with because you don't have a mechanized system to control the rate of travel. You don't, and the pressure in those is, particularly on the little 2 or 3 gallon sprayer, it's a little bit harder to control that pressure. The nozzling on those can be quite cumbersome. Some of them are just a solid cone. Sometimes you can put a T-jet nozzle in and make that different. Those are just much harder to accurately dispense a needed volume or concentration of chemicals. So I've done a lot of work with the orchard type sprayers to determine rates, and generally you should calibrate your sprayer at least the beginning of the season to know that it's doing what you want to do. In my little grape sprayer, it's real easy for me to evaluate how well that's doing because I know generally how fast I drive, and I know that 400 gallon tank should cover certain volume of area. And if as I'm working and put that out, if I come to the realization that I've sprayed 3 or 4 more rows than I should, I know I've got an issue. And quite often when I get to that stage, I'll need to go back and look at the nozzling on the sprayer. What will normally happen if I cover too much territory, I'll take the nozzles off and I'll find that I've got some of my nozzles that are partially stopped. So if I've got a bank of 7 nozzles on each side of the spray, it takes me about 30 minutes to spray out 400 gallons of water. But if it takes me 35 to 40 minutes, I know that something is impeding some of those nozzles. And I go in and take those loose, and I've got little strainers in there, and quite often you'll find some obstruction. There may be some particles of rust or something that has clogged that strainer. It's going to reduce the volume of material that's being expelled from that sprayer. And that's why that it took me an additional 5 to 8 minutes to put out that 400 gallons and allowed me to cover an additional 4 or 5 rows. So, it's the knowledge of the equipment that you're using and so forth can usually tell you when you've got a problem. As we talk about, hi there, Rachel. As we talk about the calibration of these things, the same thing has to occur, that you have to be aware that all your nozzles are free flowing and doing what you need to do. The way that I was talking about calibrating those, you determine the volume of liquid that has been dispensed over a given area. You can also measure the volume of liquid that is coming from a single nozzle for a designated amount of time and come up with the number of gallons per acre that would be traveling. That's a little bit harder for me to do, but it is doable. We'll look at I think a scenario or two that shows that. But we're talking about calibration of sprays and so forth today. Tom's not there, and your pretzel eating buddy's not here yet this morning, so we're talking about that. Talking about the application of different materials and how essential it is to accurately know how much of the pesticides you're putting on. And we're talking about primarily the use of sprayers and so forth. But it also comes into play when we're using pesticides on our animals. You know, I know you're a horse lover. Do you ever apply any insecticides to your horses? Fly spray, okay. She's a little, her volume's a little reduced this morning, so y'all may not have heard her. She said she will apply fly spray to her horses. How do you do that? She said just spray it on. What kind of solution? What do you do?
I use the whatever made, like already made up.
All right. Ready to use. Okay.
And then water mix.
Okay. Okay. And how did you apply it? What kind of equipment did you use?
Bottle.
The spray bottle. Well, now you're doing exactly what I wanted you to do. So, you know, as we talk about that type of application, how would you calibrate that to know that you applied the right amount of your solution to your animal to control your flies? How would you know? You don't.
No.
You don't.
Not much where I'm at, I guess.
And that's an example of what we're talking about. I was talking about how small handheld sprayers and so forth, how hard they are to calibrate. And Rachel's using a ready-to-use material that she buys to control the flies on the face of her horses. And most of the time, those are mixed in a manner that's safe. You can't overdose it, in other words. So that's why it's done that way, because you know they recognize that application is really hard to do. Carol, you and Jonathan have any experience with application of anything?
I use Roundup in a backpack sprayer.
Okay.
And sometimes I'll use a pesticide. I can't remember the exact name. I use it with those pump sprayers, the little handheld.
Yeah.
I'll use that on the garden and stuff.
Okay.
And we got a little.
And you can appreciate what I'm talking about, how hard it is to accurately measure or accurately apply that.
Yeah.
You know, your Roundup that you're talking about, how did you buy it? Was it in a ready-to-use material, or was something you had to mix with water?
Well, the guy that I work with, he has the pesticide license, and he buys it by the gallon. It's like, I think it's like 8 ounces to a gallon or something.
Okay. All right. Now that's a 41% material if he's buying full strength. Now, if you're talking about 8 ounces per gallon, that may be a weaker strength. That's probably about an 18%.
Yeah.
If you spraying for? What were you?
Sir?
What were you treating? Grass, what were you trying to kill?
Yeah, grass, just weeds on the fence line.
Okay, okay. And, Roundup is a material that is dose dependent. In other words, for what you're talking about, you use a relatively low concentration for grass and stuff on the fence line. If you've got, if that rate would be a 1% solution. If you're going to have something a little stronger with some briars and so forth, you need a 1.5% solution. And if you've got, honeysuckle and heavy blackberry briars, that's going to take a 2% solution. But the point I'm getting at, the way that you apply that with your knapsack sprayer, you're pumping up the handle with that, and as long as you keep that pumped up, it's a fairly constant pressure.
Yeah.
So in theory, you could, walk a given area and determine your rate of application for that. But in your situation, what you were doing was making the dose proper for the material, for the target that you were doing, and you were spreading it to wet, is basically what you were doing. You wanted to wet that material. So, in that situation, your calibration is not as critical as if you were dealing with another crop and something, because you were dealing with the herbicides. You wanted to take out those undesirable plants on your fence right now. Carol, you had any experience with any sort of application or equipment?
Just the rotary spreader with this.
Okay.
With the 7.
Okay.
And then the rotary spreader. I
Yeah.
never with a wand or anything like that. I haven't tried.
Yeah. Well, in the scenarios that both of you mentioned, you're using materials that are really safe, and you don't have a real concern about an overdosing of those. So it's not a big deal. Mr. Tyler, we're talking about calibration and the use of different types of spray machines to apply different chemicals. Do you have any experience? Because we've talked about everybody else. Do you have any experience with application of pesticides of any type and application equipment?
I've used Roundup a few times before around my rose garden.
Use Roundup? Is that what you said?
Yes.
Okay. How did you apply the Roundup?
How did I apply it?
Mm-hmm.
Well, first I got some gloves on because I didn't trust that stuff as far as foliage. And then I just went about spraying any of the weeds that popped up in the rose garden.
Okay. What type of spray did you use? That's what we're talking about.
It was a pressure pump that my dad had.
Okay, that's fine. That's very much like what Jonathan was talking about. And Roundup again is a dose dependent material, and you're not going to dramatically hurt anything with that. So your rate and so forth is not as critical.
Yeah, my dad had pre-mixed it for me.
Okay.
And put it in the container. All I had to do was sit there and pump it a few times, and then just go about spraying the weeds.
That's. And you come in and laugh and then giggling. What kind of mischief you been up to?
Waking up really late.
You got an extra hour of sleep and you're waking up really late? How do y'all think we need to punish that young lady? We'll ask her the same question we've asked everybody else. We're talking about the calibration of the application of different pesticides. And everybody's had some scenario about how they have applied a pesticide of some sort, whether it be Rachel's fly spray to her horse's face or Tyler's Roundup to his rose garden. Jonathan's been applying Roundup to a fence row, and Carol's been applying 7. So you're in the barrel. What have you applied? Whatever, Mom. What kind of equipment did you use to apply with whatever?
Spray thing.
Spray thing?
Bottle connected to the nozzle.
Okay. Yeah, she's got a different type of equipment that she's used. She's used what they call a spray that goes onto your water hose, right? And that's basically, it administers a designated gallon per acre or gallonage per a given area over amount of time, as long as your pressure is fairly constant with your water hose, and it's going to draw out the pesticide in that situation. So it's interesting that the five of you have all come up with a different type of application. Then that's fine. But as we talk about, how would you calibrate that particular application that you need? How would you adjust the calibration? You don't know. Oh, you do.
Mama just makes you come out there and do it.
Mama makes me do it. All right. She's mean, isn't she? Yeah. All right. Think about the variable factors. You're using a device that is set up to meter out a designated volume of the chemical that is in that device. And as long as the pressure from your water hose stays fairly constant, what is the one variable that you're going to be able to control as you are putting that on? No, because the amount of stuff's already in there.
The nozzle? Pressure.
Well, the nozzle, she's got a handheld device that goes onto her water hose, and it's going to have the amount of material in it that is supposed to be for that application. The only factor that she can adjust is how fast she walks or how much she moves, because everything else is going to be fairly constant. Am I wrong? That's fine. I'm picking on you because you relate. That's fine. As we talk about calibration, we got to determine what factors that we can adjust, and it varies with all types of excuse me. It varies with all types of pieces of equipment and crops or scenarios that we're using. Rachel could control how much she puts on her horse by how much it wiggles. If it turns its head, she didn't get as much on it. Do you ever have any problems with insects, worms, or biting flies that cause a problem in the horse?
Fly bots.
Fly bots, okay. Tell them what a fly bot is.
Like it flies eggs.
Mm-hmm.
These little yellow dots on your legs. And the horse eats it and then gets sick.
Mm-hmm. So, that's another scenario. Sometimes, I don't know whether it's true on horses or not, but on beef animals, occasionally they're concerned about a boring type of fly that gets on their back. And they'll use some type of application of an insecticide on the backs of those animals. And sometimes that's applied with a spray, but a lot of times it's done with a wick type system that the animal will have to walk under, and it actually dispenses the solution on the back of the animals. So the factor that would control would be how many times that animal went through, how many applications.
Or if you were my high school teacher, you'd be able to make us do an entire draft horse manually with a manual bot flyer and egg remover.
Was he mean to you? You said
Explain
how that was done.
This was a fine tooth comb, and we were there for about 2 hours brushing that horse.
I use my knife to scrape them off.
So you're using a physical type of control instead of a chemical control.
That's what he made us do. It was not fun. The horse didn't even have them. He just wanted us to know the motions of it.
You didn't like that?
It was tedious.
Why was it tedious?
Because the horse didn't want to stand still.
You didn't tell it to stand still?
She was one of the ones that hadn't been broken in yet. So she had a habit of just roaming wherever she pleased, even with 5 or 6 students standing around her.
Did she also have a habit of kicking?
Thankfully not. She was a very well-tempered horse. She
Okay.
just had a habit of walking away.
Walking away, right. But, as we talk about calibration, the goal with most of these types of things is to apply the chemical in a uniform manner. And if we're talking about these handheld devices that the majority of you all have experience with, that uniform delivery is tough. It is really hard because of the variables that are there. It's a lot easier to use a mechanized or tractor-driven type of piece of equipment because you can control it. My voice is going to go away here in a minute. I can just tell. All right, the way, even for handheld equipment, would be to determine a designated area that would be comfortable. So you could be able to determine the square footage on what you're applying. And that's fairly easy to do. One of the things that you need to do is a lot of these commercial or chemicals that we use, the rates are given on the basis of pounds per acre or ounces per acre. It's given on a per acre basis. So if we begin to think about this, what is an acre? We talked about this a little bit.
Measure of land.
Yeah.
An acre is 43,000. What was it? Was it 2 or 560?
5.
Okay.
What?
43,560 square feet.
Yep, 43,560 square feet.
Yes, sir.
So if you were to spray an area that is 10 feet wide and 100 feet long, how much would you have covered? Rachel's grinning at me. So 10 by 100. 1,000 square feet.
Yes. Final answer.
So if that was the area that you were gonna figure on, and you figured that you had used a designated amount of water in spraying that, you could figure what your rate would be based on a given acre. The 1,000 square feet is not very much compared to the 43,000. So we're going to talk about these different rates as we move along, but that's something I want you to be aware of, because it's essential to know how to do that. And I was just looking here at the steps that it goes through in the textbook, talking about the calibration, and it talks about the spray volume is being determined by your tank size, which is whether we're talking about a Jonathan's backpack sprayer that's 3 gallons, or we're talking about Rachel's handheld device, which holds about a quart. And Tyler's tank was probably 2 or 3 gallon tank. What would you think? 2 gallon tank. So, it makes a big difference when we're talking about it, when we go to talking about calibration. And the other factors that we're talking about are your pressure that your pump delivers, and the nozzle or the flow rate, which can be determined by your orifice and your operating pressure. There are a lot of factors that we need to talk about as we do that. And like I say, I want to get some little problems that we're gonna work through, to give you some better ideas about those. But that's the gist of what we're gonna talk about. I'm trying to decide. All right, there is a video on, and I haven't looked at it because I think they changed it. Let me play with this a little bit, and I'll see if we can get it up. I hadn't originally planned on doing this today, but we're to a point that,
Filler content.
well, no, it's not so much that. I'm to the point that I don't have, we need to look at it. Carol, you guys, I'm going to try to get this video started, and then I'm probably going to shut it off and come back and see if you guys can see it. So,
Yes, sir.
this one's going to be really short. That's not, they've changed it. Were you able to see that?
No, sir.
No?
No.
Phooey. You're laughing at me. I know you are. That's okay.
It was the screen, Jonathan was, never mind.
All right, that's okay.
We're not laughing at you. We want to help.
That's well. Look, I think it's pitiful, but that's all right.
We're not sure if we're supposed to be doing something on the.
You shouldn't be. You shouldn't have to do anything if I can get this to work properly. So, just hang with me a minute. Let me see, because I
We're seeing the back of Tyler's.
turn this other screen on in the back. Maybe I can tell a little more about it. But I know you've got to be able to see my computer to get it to work, and I can't get that to shift over this morning.
Well, if we could watch with y'all on y'all's screen.
Well, let me try this, because on my screen it's pretty bad. So hang on a minute. Let me see if I can get it on.
I don't think it's.
There it is.
Were you able to see that?
Yeah,
Okay, I'm gonna go back and we're gonna try to play this. Okay.
all right.
Hello and welcome to Fundamentals of Calibration,
I remember this one.
training program about the calibration of pesticide application systems. Before we start, there are a couple of things to get out of the way. These two gentlemen are Herb and Clifford Fisher. That's Herb on the right. Clifford is his younger brother. In the past, we have always tried our best to use pesticides and fertilizers properly and to keep our equipment in good operating condition. But today, we use a lot more chemicals. We apply pesticides and fertilizers to millions of acres of farm and forest land every year. And we have to ensure proper use, not only for the sake of effectiveness, but also to protect the environment. The improper use of chemicals could be dangerous, illegal, and a waste of money. That's why equipment calibration is critical. We need to be able to measure the performance of our equipment accurately and consistently, to be sure that it conforms to operating standards and that it delivers chemicals in the right amount and in the right places. And that's what this program is all about, to help make you a better pesticide applicator. If you go all the way through this program, you'll cover 4 sections. This is the introduction. Also, there's a presentation section that describes the components of calibration and how they affect application rate. The 3rd section is a simulation of a calibration exercise in which you will be asked to calibrate a sprayer system. But be aware that most principles of calibration apply to other types of systems as well. Finally, we have some questions to help you find out how much you've learned. If you are new to this, you may wish to study the sections in the order presented. You may begin now. The 8 factors shown on the screen represent the underlying concepts common to all sprayer systems. Achieving proper application rate is the primary objective of equipment calibration. System flow rate directly affects application rate. You may wish to study these 2 most important sections first. The other 3 factors that directly affect application rate are the speed of your sprayer, the concentration of chemical in your tank, and the width of the swath the spray comes into contact with the target area. Likewise, flow rate is affected by 3 additional factors. They are the size of the opening or orifice in the nozzles being used, the level of pressure of the system, and the number of nozzles attached to the boom. After application rate and flow rate, you may wish to study each of these factors until you understand the manner in which they interact. You may now choose an area to study. We will define application rate as a measure of the amount of active ingredient being applied by system. Application rate usually is expressed as a weight per unit of area. For example, pounds per acre. The recommended application rate and mixing directions for each chemical always are found on the product label. Don't let mixing directions confuse you. In practice, the application rate often will be expressed in terms of gallons of tank mix per acre, rather than as weight of active ingredient. This allows you to calibrate by measuring liquid sprayed from the tank. Application rate is the critical factor in pesticide application for a number of reasons. First, effectiveness. Too little of the proper chemical may not solve the problem. Then there's safety. If you apply pesticide improperly, you can contaminate groundwater, harm wildlife, endanger public health, and leave chemical residues on crops. There's economics. If you use more of a chemical than is needed, you could waste a lot of money. Which leads us to the last consideration, legal responsibility. You can be liable for any damage that results from your improper use of chemicals. So, if you spray too much insecticide on a field, then it rains and all that chemical washes into a creek, kills fish, or pollutes the water system of a nearby town, you can be liable for the damage. Application rate is determined by the interaction of 4 factors. These factors are the concentration of the chemical in the sprayer tank, the speed of the sprayer system during application, the width of the spray swath, and the system flow rate, that is, the rate at which liquid is sprayed from the system. This last factor, flow rate, in turn is affected by system pressure, the number of nozzles, and the size of the nozzle opening, often referred to as the orifice. A change in any of these factors will force a change in application rate. In sprayer systems, application rate is usually measured by spraying water over a previously measured area. The amount of water required to refill the tank is equal to the amount of water sprayed during the test. A formula or table may then be used to determine the application rate of the system during that test. If the application rate is not correct, adjustments can be made, usually to speed or flow rate, and the test performed again until proper application rate is achieved. In boom sprayer systems, swath width is the distance along which the spray hits the ground, shown here. Swath width is normally determined when a sprayer system is configured and should remain unchanged during calibration and application. Directions for mixing the proper concentration of the chemicals are found on the product label. Concentrated pesticides and fertilizers, both liquid and powders, normally are mixed with the liquid and water before application. While concentration normally is not adjusted during the calibration process, a change in concentration has a direct effect on application rate. In this demonstration, beaker B is receiving double the chemical as beaker A. The concentration in beaker B is therefore twice that of beaker A, even though both have the same amount of water. If these two mixtures were applied by identically calibrated sprayer systems, the application rate of system B would be twice that of system A. This chart shows the direct relationship between concentration and application rate. Application rate changes in direct proportion to concentration. If the concentration is doubled, application rate will be doubled. Concentration is cut in half, the application rate will be cut in half. But remember, concentration is not a factor that is normally changed during calibration. The speed at which a sprayer system moves across the ground affects application rate. Speed is one of the factors most likely to be changed in order to adjust application rate. The relationship between speed and application rate is shown in this demonstration. Notice that at high speed, little paint is applied to the surface. When the can is moved at a slower speed, the area is covered more thoroughly. Thus, speed and application rate are inversely related. That is, as speed increases, application rate goes up. Flow rate is the amount of liquid sprayed by the system during a specific period of time. It is measured in gallons per minute. Each nozzle has its own flow rate that depends upon the size of its orifice and the amount of pressure forcing the liquid through. The flow rate of an entire system is the sum of the flow rates of all the nozzles in that system. For example, let us assume that all the nozzles in this system are identical, clean, and in good condition. If the flow rate of the first nozzle is 1 gallon per minute, then each nozzle has a flow rate of 1 gallon per minute. Since there are 10 nozzles in the system has a flow rate of 10 gallons per minute. During calibration, the system flow rate normally is determined by measuring the flow rate of several nozzles and then multiplying their average flow rate by the number of nozzles in the system. Flow rate has a direct bearing on application rate. The higher the flow rate, the higher the application rate. All other factors being equal, a doubling of flow rate will cause a doubling of application rate. If flow rate is reduced by half, application rate will be reduced by half. If any of the factors which affect flow rate are changed, flow rate will be changed, and thus the application rate will be changed. Another factor affecting sprayer operation is the amount of pressure in the system. Liquid is forced out of a sprayer system by pressure, much as air is forced out of a balloon. Pressure is measured in pounds per square inch by a pressure gauge attached to the system. Different types of nozzles are designed to deliver specific amounts of liquid at predetermined pressures. This information is available from your distributor and is taken into account when you configure the sprayer system. Increasing pressure increases flow rate. Conversely, a decrease in pressure will result in a decrease in flow rate. The relationship is not direct. In fact, to double flow rate, pressure must be increased 4 times. To triple flow rate, pressure must be increased 9 times. In practice, changes in pressure can be used to make small differences in flow rate. The number of nozzles on the boom is one of the factors that affects the flow rate of the sprayer system. All the nozzles will be identical in most spray applications. The flow rate of the system is the sum of the flow rates of the individual nozzles. Because all the nozzles are the same, system flow rate is usually determined by multiplying the flow rate of one nozzle by the number of nozzles on the system. Doubling the number of nozzles will double the system flow rate. Likewise, quadrupling the number of nozzles will quadruple the flow rate. The relationship between number of nozzles and flow rate is direct and linear, as shown in this graph. For example, all other factors being equal, the one nozzle system has a flow rate of 1 gallon per minute. Then adding one more nozzle to the system will raise the system flow rate to 2 gallons per minute. Adding a third nozzle will raise the flow rate to 3 gallons per minute, and so on. Remember, this assumes that all nozzles are of the same type and size, are clean, and in good condition. Thus, an increase in the number of nozzles results in a proportional increase to flow rate. The opening through which fluid passes is called the orifice. Orifice side nozzles is the major factor affecting the flow rate of any particular nozzle. Orifice size is represented by the diameter of the opening and is usually measured in thousandths of an inch. The size often is stamped right on the nozzle. Orifice size is determined when the sprayer system is configured and may be changed to make major adjustments to flow rate. Of course, dirty or worn nozzles will not perform properly and should never be used when spraying. The opening at the end of a hose is an orifice. So you can see that these two hoses have different sized orifices. The larger orifice has a higher flow rate, and more water flows out during each second that the hose is on. Under equal pressure, a nozzle with a larger orifice will have a higher flow rate than one with a smaller orifice. An increase in orifice size will result in an increase in flow rate. The relationship is not direct. Doubling the diameter of the orifice quadruples the flow rate. Reducing the orifice size by 1/2 will reduce flow rate to 1/4 of what it was.
Okay, that is a video that's been on that tech site for the last 7 or 8 years when I've done this. And I'm a little surprised they've left it on there because it's kind of dumb. But it does explain a lot of the things that we're talking about with pressure and orifice and flow rate and so forth, which are key factors in determining our calibration. So, in Jonathan's application of his Roundup, he wasn't really concerned about a uniform flow rate. He was trying to spray, or uniform rate of application, but he was trying to kill those weeds, and he was spraying it to wet. And that's what you got to do with that type of application. But were he to have been putting down a pre-emergent herbicide on a strip of his garden where he wanted to eliminate weeds before he planted his beans, that would be critical. And it's a whole lot harder to do with that type of piece of equipment. Now, if you're using something like what these two clowns were using in this video, you're able to do that by the manipulation of the pressure, the size of the orifice, and the rate of travel for the individual sprayers. So, we're going to talk about this some more when we get into it, maybe on Wednesday. There's another series of videos that come with this, and maybe by then we'll have had time to get some examples done for you, so you can get a little better feel for it. They'll be in the private pesticide applicators test. Some of the tests will have a question in it, a question or two about calibration. So I want to make sure that you're prepared for those when we do those. So, but that's sort of what I had intended to cover today. We're about out of time, so enjoy. Have a good day. Those two clowns, they've been that way for the last 8 or 10 years. They haven't matured at all. So let them go. All right, y'all have a good day.
Have a good day.
Thanks.